This is chapter 10.1. This is our introduction to algebra. And a lot of people, when you start to hear about the term algebra, start to get a little scared. When we name math, when it becomes algebra and trigonometry and calculus and all that, people tend to get scared. And we need to get rid of that fear. We need to eliminate that. One of the ways to remember this is that we actually have been doing algebra all year long. We've been working through some processes that really focus on the basic principles of algebra. But if you're having a little trouble with it still, we're going to kind of personalize it. We're going to take algebra, and we're not going to call it algebra anymore. We're going to call it Al. We're going to give it a little personality here. We're going to give it a name. And we are going to say that Al has one very strong belief, and Al's belief is balance. What Al is looking for is balance on both sides. It may help to picture an old seesaw, an old teeter-totter like this. And over here we have person A. Person A is sitting on this end of the teeter-totter, and over here we have person B. And as long as they weigh about the same amount, then this teeter-totter will stay nice and flat, and it will stay equal, it will stay balanced. Now, Al's job, or algebra's job, is to achieve this balance and equality on both sides of the teeter-totter. And we can do that by adding, or subtracting, or multiplying, or dividing on any side, on whatever we're going to do here. Okay? Now, one of the big things you got to remember that we have talked about all year long, and you'll be able to repeat this rule several times, is whatever we do to one side, whatever we do to person A over here, we have to do the same thing to person B over here. If we don't have balance, and we're not doing algebra's job. So, here's what we have. Algebra is based on equality. That's our mission. We're trying to get equal on both sides of the equation. And we show this or demonstrate it by doing something known as pan balance problems. Pan balances are, you've probably seen them before. You have a fulcrum in the middle and then the lever, and then over here you have a big pan, and over here you have another one, and you can put stuff in these. And you try to balance it out. You try to get the weight of something over here to equal the weight of something over here. And that's kind of what algebra starts with. Here's a simple pan balance problem. Okay? We have a box on this side, and that box right now is perfectly balanced with 3 circles over here. And that is illustrated down here. One box, or one square, is equal to 3 circles. And if they weren't equal, this pan balance would be off, and it would be either up over here or up over here, whichever. So right now we've got it perfectly balanced. You all know the rule. The rule is written down here. And it says, what you do to one side, you must do to the other. In order to achieve balance, in order to keep Al happy and have the balance right, we need to make something happen on both sides. So let's say over here, to the square, we add 2 circles. Now we're off balance. So what we need to do is we need to do the same thing over here. Adding 2 circles over here creates balance again, and Al is happy. And algebra has done its job. And so we would rewrite this as a square and 2 circles is equal to 5 circles. And really what we did is we added 2 circles over here, and we added 2 circles over here. What we do to one side, we have to do to the other. That's the basis for algebra. Now what you can do is you can use that to solve problems with pan balances. You look at this setup. We have balance. We have a triangle and 2 squares is balancing 3 squares over here. Now my question is, one triangle equals how many squares? So what you have to realize here is what you're trying to get is one triangle all alone. And right now this triangle is not all alone. In fact, this triangle has 2 squares with it. In order to get the triangle alone, let's get rid of these 2 squares. We can subtract 2 squares. Well, now we have our triangle all alone, but we're unbalanced. Our rule is what we do to one side, we have to do to the other side. So since we took away 2 squares here, we have to take away 2 squares here. And what that leaves us with then is just 1 square over here. So our one triangle is balanced with our 1 square, and therefore the answer to our question here is 1. One triangle is equal to one square. And that's how you can set this up. That's how you can use these equations to help you out. Now here's a situation. Similar, we have a circle and 3 triangles is balanced with 5 triangles over here. We want our circle alone. The question says one circle equals how many triangles? Over here, we have 3 extra triangles we've got to get rid of. So we're going to subtract 3 triangles. What we do to one side, we've got to come over here and do to the other side. So we're going to get 3 triangles off over here. And that leaves us with 2 triangles here. One circle balanced with 2 triangles. That fills out our equation. One circle equals 2 triangles. Now sometimes they can get a little goofy. You know, it doesn't have to be triangles and it doesn't have to be squares and circles. Let's go a little different here. We have half a pizza. It's a pepperoni pizza. And that is balancing with 2 cups of hot chocolate. See, it's written down here. 1/2 of a pizza equals 2 cups of hot chocolate. But here's my question. I want to know, if I have 1 pizza on this side, how many cups of hot chocolate do I need to balance it? Now, in order to get 1/2 of a pizza to be a full pizza with pepperonis, you have to multiply that pizza by 2. Because what you should remember is 1/2 times 2, which would be the same as 2 over 1, equals 2 over 2, and that reduces down to 1. What we do to one side, we have to do to the other. So we multiplied by 2. You have 2 cups of hot chocolate. You've got to multiply it by 2. That would give you 4 cups of hot chocolate. So your answer there is 4 cups of hot chocolate. This can get a little difficult. Okay, it can move into just algebraic expressions. And this looks a little goofy. 2x plus y balances, or is equal to right now, x plus 3y. The question is, I want to know what 1x equals. That's what I want to figure out. So I've got to break this thing down. I've got to get 1x all alone, or I can get 1x all alone over here. Either way. But I'm going to start with over here. Okay, I want 1x all alone. So let's get rid of the y. How would I get rid of the y? I can just subtract it. Get rid of 1y over here. What I do to one side, I got to do to the other side. So I'm going to subtract it from here. So 3y's minus 1 leaves me with 2y's over here. And this is gone. And now what I've got is 2x's here and 1x over here. I don't want 2x's, I just want 1. So I'm going to take 2x's and I'm going to divide it by 2. Now the problem is, though, I can't do that over here. I'm not going to use division. What I am going to do is I'm going to take 2x's and subtract away 1x. 2x minus x. That leaves me just my x, 1x. And I have to subtract an x from this side. An x minus x leaves me nothing. And x then equals 2y. Now, this thing right here, this is complex. It's difficult. This is the hard part about algebra. If you didn't understand this part, that's fine, because we are going to be moving into this a little more later on. Try some of these, see if you can get them. If not, back up and look again at our pan balance problems. Start with the simpler ones, get the concepts, and then work forward and try to come back to these. They're very difficult, and it may take you a little while, but we will work on these again in class.